Previously, we've seen how we can get a insoluble salt to precipitate out of solution by increasing the concentrations of its counter ion in the solution. And now what we're going to do is utilize this idea to get a particular ion of the insoluble salt to almost completely precipitate out of solution by adding a relatively large amount of the counter ion to the solution. So here, what we're starting with is nickel 2 plus, and it's dissolved in water. And what we want to do is to try to get as much of this nickel 2 plus out of solution in the form of a precipitate. So how we do this is by adding in a solution that contains S2 minus, because nickel 2 plus and S2 minus combine together to make a very insoluble salt, nickel 2 sulfide. So overall, what we're going to be looking at is what's going to be this final concentration of nickel 2 plus if we vastly increase the amount of S2 minus. So remember, because this is an equilibrium, we can never really truly get this concentration of nickel 2 plus all the way down to zero, but we can decrease it quite a bit. So in this question, we're looking at two different pieces, and these are both important questions you should be able to answer in terms of solubility products. So the first one is, well, what's the concentration of S2 minus that we need in order to begin precipitating our nickel 2 sulfide? So when we look at this, this is going to be right on the edge, and we'll know if we increase the concentration of S2 minus, we're going to start forming a precipitate. So what we do then is we're going to push this concentration of S2 minus fairly far to 1 times 10 to the minus 4th molar, and then we're going to find out what's going to be the remaining concentration of nickel 2 plus in solution. So we're going to find that that concentration is going to be much less than what we started with up here. So as always, we need the solubility product for our insoluble salt. So that's given here, and then we need to consider the equilibrium. So here, nickel 2 plus is formed along with S2 minus, and the solubility products here. So remember, we don't include nickel 2 sulfide is part of our solubility product, and it's just the concentrations of nickel 2 plus times the concentration of S2 minus. So here what we're looking at is we're saying if we want to be right at the equilibrium, right at the limit of the solubility, we want to know what's this concentration S2 minus. We have the KSP, that's a constant. We were given the amount of nickel 2 plus that we started with. So if I just solve this for S2 minus, that will tell me at what concentration of S2 minus will we be right at equilibrium. So divide the KSP by our initial concentration of nickel, we get that when S2 minus is at a concentration of 3 times 10 to the minus 19th molar, we are just at the equilibrium point. So this means if I increase the concentration of S2 minus any more than this, we're going to start getting a precipitate out. So you can see this is a very, very small number. So this is a relatively very insoluble salt. So you're going to see this is going to be very effective for removing our nickel 2 plus from solution. So right here we know if we increase the concentration, we're going to start getting nickel 2 sulfide out. And now we say if we increase the concentration of sulfide to 1.0 times 10 to the minus 4th, what's going to be the concentration of nickel 2 plus? So remember, we're still starting with our solubility product here, but now the constants are KSP, and now we're giving you a concentration of S2 minus, and we want to say if we have that concentration S2 minus, what's going to be the concentration of nickel 2 plus in that solution. So a bunch of the nickel is going to precipitate out, and what we want to know is what's left over in this case. So I solved that equilibrium in terms of nickel 2 plus, so it's KSP divided by the concentration of S2 minus. So remember, the concentration of S2 minus was given up here, and what we solve for is the concentration of nickel 2 plus that will be in solution after the precipitation occurs. So KSP divided by the concentration of S2 minus, that gives me the concentration of nickel 2 plus that's left over, which is 3.0 times 10 to the minus 17th. So this is a very small amount. So remember, we started with 0.01 molar, and by adding in a relatively large amount of S2 minus, we have almost completely got the nickel 2 plus to be removed from this solution.